This is a demo of our voice cue feature from Audience, where we use voice to enable us to communicate with the device and to wake it up. Right? One of the key advantages of the voice cue feature is that it is very low power. We do it in 3 stages. In stage 0, it is listening for voice activity. So if I'm not talking, it's in the very low power. Once it detects voice, then it goes to stage 1, where it listens for the key phrase. For example, it can be "Okay, ear smart," and that's our keyword, or it could be "Hi Galaxy," or anything. And once that keyword is detected, then the system goes into stage 2 and wakes up the AP. The way this is different than other existing solutions is the other existing solutions listen just for the loudness. We don't listen just for loudness. You can make this environment very noisy and our chip can still remain in very low power. Okay, so I'm going to demo the voice cue feature here. Let me make sure I enable it. So here I've activated voice cue, and I'm going to say our key phrase. So I have this acoustic handset, and I'm going to say, "Okay, ear smart." And as you see, so I'll explain. At the very early, when I wasn't talking, there was just some normal trade floor noise. This was stage 0, so very low power. Then when I started talking, it detected voice and it went to stage 1, listening for the keyword "Okay, ear smart." Once it found "Okay, ear smart," that's when it woke up the applications processor and it went to full power. So this is a demonstration of the voice cue feature from Audience.
Very good.
Okay. So this is a demo of our sensor fusion technology based on our motion processor. We have an acoustic handset here, which has 3 types of sensors: an accelerometer, a magnetometer, and a gyroscope. What we are doing is we're taking data from these sensors and showing how we can process and how we can do sensor fusion. So if I move this ID, you can see that there's a teapot here, just for demonstration purposes, right? I'm rotating. Or if I move it this way, you can see that based on our sensor fusion intelligence, it knows whether I'm going forward, or I'm lifting upwards, or I'm going left, right? Now, one of the advantages of our technology is that we have a floating point based DSP, so we can track very fine movements. So if I move the handset very slowly, it can track that, or coarse movements, right? Very large movements. We're able to get this accuracy with high power efficiency due to an advanced floating point DSP. Okay, so this is an example of a motion-based sensor fusion intelligence demo.
Amar, thank you.
Right. Okay, so this is a demo of the motion cue technology from Audience. It's what we have here we have an acoustic handset, and it has a magnetometer, and it can track where the true north position is by the rotation of the purple EarSmart logo from Audience. Right now, an example of how we fuse intelligence from sensors is if we take a phone which has a strong magnet in the earpiece, and if I bring it close by, if I bring it close by, you can see that the magnet is trying to deflect the magnetic field, right? And we have an interrupt here alerting us that the magnet is trying to interrupt it. But the true north position will not change. It will only change if I move the actual magnetometer. So what the motion cue technology is doing is it is correcting for deflections in the magnetic field when it knows that it really isn't deflected. There's some external variables that's causing deflection. So this is an example of how we can fuse intelligence, and we can do that at very low power as opposed to having a discrete sensor hub that consumes more power and wakes up the application processor more frequently.
Thank you.
Okay.